Welcome back, everyone. Thanks for tuning in. Really appreciate that. All those who are actively participating each week in some of these learning opportunities. Again, they're all voluntary, but thank you for all those putting in the time and effort. We're in week 8, part 3. We're going to be going over matrix multiplication today. That's kind of our main topic, and so let's go over the Google form answers that I sent out on Sunday. Now, just a reminder: next week is our last week of doing this stuff. For all of you guys, you're kind of wrapping up your year here shortly. Congrats to all of you that are graduating and whatnot. And so I wish you the best of luck in the near future. And if you need help on math, you know where to contact me. But let's jump right in here, and hopefully we can get through these. So, all right. Okay, so what you're looking at here is my iPad. We're going to be doing matrix multiplication. Now, the big thing about matrix multiplication is you just need to realize the dimensions. So like it's a 1 by 2 or it's a 2 by 3. So it's rows and columns. So rows are the horizontal, and then columns are the vertical lines. So just keep that in mind. You do need to know your dimensions to check to see if it works. And that's actually what the first question is based on. So on the Google form, it was out of these, which products would not exist? That you just can't do it. The dimensions don't work out. So 3 by 2, 2 by 3, 2 by 2, 3 by 3, that type of thing. So there's lots of different combinations, right? You could go, now I'm not saying that these all work, but I'm just saying that each of these in their own are different. They give you different results. So you have lots of different options. I found the dead spot in my iPad. It won't let me write. Just let me write that. All right. So we have lots of different combinations here. You can have up to 16 different combinations. I have AC, ABs, ADs. Then BCs, BDs. I have CDs. Do I have those? No, don't have those yet. CD and a DC. So what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12? Is that the only combinations I have? I thought there was more, but maybe it's just because of repeating. So, alright. So, anyway, some of these would not exist. Now, the reason why is that, let's say I'm going to go A and B. This is matrix A's dimension. This is matrix A, and matrix B is a 2 by 3. This works, because what I reminded you of is that when you're going to multiply matrices together, the two middle dimensions that are closest to each other have to match. The final answer would be a matrix that is 3 by 3, the outside dimensions. So that one checks. Bing, that one's good. Maybe let's try to find one that wouldn't work. So let's go like the CD route back here. Matrix C is a 2 by 2. Matrix D is 3 by 3. The middle dimensions don't match. You can't do that matrix multiplication. It's not going to work. The dimensions don't work out. You can't do it. It's not possible. So that's something to think about. So when they say which ones do not exist, right there is one of them. That does not exist. It doesn't work out. So you can kind of most people can kind of look at this and go, okay, I get the idea now. I know, for instance, BD is not going to work. Because, or DB, I should say DB, not BD, but DB. That one's not going to work. I must have wrote it BD twice. DB doesn't work because D ends in a 3 and B starts in a 2. So it does matter the way you write it. So D had to come first, B came second. So that's why the big question is, are these commutative? No, they're not. Are they associative? Maybe. If you're gonna add, maybe, or subtract, just depends what you're going to be doing. It depends on the math, but they're not commutative. You can't just flip them and expect the same answer. So keep that in mind. There's only certain matrices that could work that way. They're very unique. It's special. Usually they have to be given that. So keep that in mind as we go through some of these problems. You'll get different results. So when you look at some of these slides, you're like, Ward, you just gave me the same matrix. But when you flip them, the answers would be different. Especially in a 2 by 3 and a 3 by 2. Very different in terms of numbers. So let's jump right in here. So this is the first one that I had on the slide, and this is by far kind of the most challenging question. They're telling you that on this particular case, and this is special, that's why I brought this one up, the matrix multiplication is actually the same when you flip them. It's commutative between these two. And you have to find x. So why this is important? Multiply row by column. So when I go, I'm going to go the AB route. That first column is 1 times 1 plus the x times 1. That's that first entry right there, right? And I could do it again for the second entry. Row, column, right? So 1 times 1 plus 2 times x. That entry. Then I'd move on to the second one. I wouldn't have to deal with x's anymore. But when I flip it around and I go b times a, I might have to get rid of my camera here just so you can see. When I flip these two around, let me get rid of these markings. Now I'm doing matrix B first. So I'm going row by column, because the B would technically be the first one, so you have to do the rows first. So 1 times 1, and then 1 times 2. So there's that location. And then the next one is row, column going this way. So 1 times x and the 1 times the 3. There's that one. So you're starting to see like the purpose of us doing this is because these matrices have to match. So by just finding this first one right here and here, these matrices have to be the same. I can actually solve for x. I should be able to figure out what that answer should be. That answer should be, I think x should be a 2 in this case. But let's just kind of solve and figure out. So 1 times 1 is 1 plus x is equal to the 1 plus 2 in the next matrix. So I'm just setting this entry and this entry equal to each other and just doing the math as I go. So this is 1 plus x, and this is a 3, and so this, if I subtract this over, so my x should be a 2. And that should make both of these matrices match in the long run. Just to prove the point, if I plug a 2 up here, that's 2 times 2 plus 1 times 1, so this should be 4 plus 1, so that should be 5. This should be a 2, so it should be 2 plus 3, and yeah, that should be a 5. So that entry should be a 5 and a 5. So this number should make both matrix multiplications work out if I were to plug in a 2 right here for this x. Again, this doesn't always happen. That's why I said this is a very special case that your commutative property actually worked for multiplication here. And you're going to see that in the next couple of slides that that's not always the case. You might get matrices that are completely different. They're different dimensions. They have different numbers. That's why it's kind of important that you get to see that. Okay, so let's jump right in and let's kind of look at the next one here. So we got, 7 problems, something like that. Actually 10. We had 10 problems this week, didn't we? All right, so we have to multiply matrix A times B. Row by column. So I'm just going to get you set up here, and then I think you can figure this out. Now, I definitely don't have enough space for this. My camera's even cutting in the way. All right, so I'm going to row and column here. So I'm going to go the 2 times the 5, the 0 times the -1, and the -1 times the 2. So it's the whole row for A and the whole column for B. There's that first entry. That's the upper left corner. Then I'm going to switch up color here. I'm going to go row and column. So this will be the next one. So 2 times the 1, the 0 times the 0, and the -1 times the -3. And that would be the second entry in the middle, top row. And then the last one here, row, column. So 2 times the -2, the 0 times the 4, and the -1 times the 3. And that's the upper right corner. That's how matrix multiplication works. Then when I go into the next one, So the next spot right here, it's this row, first column. And I just do the same stuff again. So the 3 times the 5, let's get rid of that dot. What do we have? The 5 times the -1, and the 2 times the 2. So that's, again, a row and the first column, entry for entry. And that's that middle left number. Hopefully that makes sense. You can go through that. You can kind of figure out what each of these numbers are. You can keep going and, you know, go to the next one, go to the next one, and you just keep going row, column, row, column, row, column, and keep going until you go to the bottom one. All right, let's jump to the next one. I think that we spent time on that one. A 2 by 2 matrix, x times y. Again, the x comes first. So again, when I write this down, this upper left corner is the row by column because I'm going x first, then y. So row, column. So 3 times the -2 plus the -1 times the -3. So there's the first column. Let's switch up color. Okay, so now I'm going to go row, column here. So 3 times the 4 plus the -1 times the 1. That's the upper right corner. Bottom left corner. So now row and column. So 2 times the -2 plus the 5 times the -3. That's the bottom left corner. And then I go to the last one. All right, moving on. I'm going quickly. I know I'm not finishing these out, but I think you can figure this out once you see it enough times. All right, let's go to the next one. Same exact idea, b times a. Now, b has to come first. This is a 3 by 2 matrix, and then a is a 2 by 3. So if I put b first and a second, this is 3 by 2, 2 by 3, and yes, these should match. These should work. The middle numbers do match, so I can actually multiply b times a. That is possible. The other ones, they're all squares, but this one, these are different dimensions, so I do have to check them. That's something I always do. I'm sorry I didn't explain that earlier, but so this matrix, the overall matrix on this one is going to be a 3 by 3. It's going to be a 3 by 3 matrix in the long run. How I know that is because the outer dimensions, when you multiply, are what you're going to be the size of. So this is going to be a 3 by 3 matrix in the long run. So row, column. So this is going to be 3 times the 2 plus the -1 times the -1 plus the 2 times the -3. And then the next one I'd go row, column. Oh, did I? Oh, hold on. Oh, I made the bad mistake. Oh, silly mistake. Amateur hour in here. I did it to myself. B times A, right? This is matrix B. That's the problem with not having them written in the right order. Oh my gosh. I almost made the colossal mistake. There we go. Okay. Apologies. All right. Row, column. There we go. All right. BS come first. Oh my goodness. Amateur hour. All right. So 2 times the 3 plus the 0 times the -2. Okay, there's the first upper left corner. Row by columns. Now I'm doing the second one. So 2 times the -1 plus the 0 times the 4. So there's the upper middle, and then row by column again. So 2 times the 2 and the 0 times the 0. Okay, so there we go. Now it's starting to make sense why we're getting a 3 by 3 in the long run. Wow. Apologies. All right, let's go to the next one. So next colors here. So row, column. So -1 times the 3 plus the 4 times the -2. So there you go. There's that first left one. So then row, column again. So now I'm going the second column. So -1 times the -1 plus the 4 times the 4. There's this. That's the middle number now. And then the row and column. So now I'm going the -1 times the 2 and the 4 times the 0. There we go. Hopefully you're getting the idea now. I didn't make a mistake on that one. finish it out. You guys get the idea, and you can figure out the numbers there. 2 by 2. So these are back to square. So now we got to pay attention which order Q and P. So Q is coming first, P is second. So I'm going to rewrite these matrices. Oop. I'm going to rewrite these matrices so I don't make that silly mistake I just did a little bit ago. All right. -2 and 5 and 1 and -3. All right, there we go. So so row, column. So the upper left corner. So my final matrix will be a 2 by 2. These are both square, so they're going to be the same size in the long run. So row times the column, row times the column number. So 4 and the -2 times the -2 and the 1. So 4 times -2, the -2 times the 1. Add them together. So that's the upper left corner. Upper right corner, 4 times the 5, and the -2 times the -3. So row by column. And then you can go on to the second one. So second row, first column. So 3 times the -2, and then the 2 times the 1. And then the same thing in the long run. 3 times the 5, and the 2 times the -3. So there you go. All right. Ooh. Okay, I take the other one's matrix P. It must be shifted off to the side. I couldn't see it. All right, so P is the first one, so we'll assume this is matrix P over here. I would assume it is. All right, so we have to multiply these, P times Q, so it's going to be a square in the long run. So row by column, so what do we have? -2 times the 4 plus the 5 times the 3. All right, so there's the first row, first column, there you go. And then the upper right corner over here, so now we have the -2 times the -2, and the 5 times the 2. So now I'm going row, column, second one there. All right, now we go to the bottom row. So bottom row, first column. So that's 1 times the 4 and the -3 times the 3. So there you go. And then we go to the next one. So we go row and column again. So hopefully it's starting making sense to you. I'm hoping that this isn't too much. We did enough of these examples on, Sunday or Monday's video, whatever one you watch. So hopefully it's starting to make sense. Same thing again. We have two matrices. We have a 3 by 3. So I'm going to write B first. So that's 5, 1, -2, -1, 0, 4, 2, -3, 3. That negative sign was really bad. All right. There's matrix B. Matrix A is the 2, 0, -1. I don't want to make that same mistake I made on the first one. Oh my goodness. -4, 1, and 4. Okay. All right. So multiplying these together, we know they're the same size, so it should work out in the long run. We don't even have to question it. So row, column. So 5 times the 2 plus the 1 times the 3 plus the -2 times the -4. So there's the upper left corner. Now I'm going to switch colors so you can see this. So row and column. So 5 times the 0, 1 times the 5, and the -2 times the 1. So that's the middle number now in the top row. And then the upper right corner is row, column. So up here, this number right here, I don't have enough space, but that number that's going to sit right there is the 5 times the -1 plus the 1 times the 2 plus the -2 times the 4. Again, it's row and column. That's where I'm getting these numbers from. Then when you go to the next row down, this number right here, that's the second row, first column. And that's where this number comes from. Then I can go to the middle. So that's second row, middle column. That's this number. Entry for entry, and then add them all up once you multiply. Okay, you can hear my dog in the background. All right. A times B. These matrices are written in the correct order, so I don't have to focus too hard on rewriting them. It's going to be a 2 by 2 matrix in the long run. Row times column, so 3 times the 2 plus the 1 times the 1. So there's the upper left corner. Upper right corner, so that would be 3 times the 3 plus the 1 times the 5. So that's the first row, second column now. Then I move on to the second row now. Second row is 4 times the 2. Again, I'm doing second row, first column. So 4 times the 2 plus the 1, 2 times the 1. Then same thing as before. Second row, second column. 4 times the 3 and the 2 times the 5. There we go. And the last question. What is 8 times b? So this is a 2 by 3, and this is a 3 by 2. So yes, the middle terms do match, so you can actually multiply these together. The overall matrix will be a 2 by 2 matrix. That's the outer dimensions. So that's kind of the opposite of what we did earlier today. So it'll be a 2 by 2 in the long run. So let's kind of walk through the math here. I think they're already set up correctly, so I shouldn't have to worry too much about it. So row times the column. So that is 3 times the 2 plus the -1 times the -1 and plus the 2 times the -3. Alright, so there's that one. That's the upper left corner. The upper right corner is the first row, second column now. So 3 times the 0, the -1 times the 4, and the 2 times 2. There's the upper right corner. And then I go to the bottom row. So bottom row, first column. So -2 times the 2 plus the 4 times the -1. And what is the last one? 0 times the -3. Alright, there you go. There's the bottom left corner. I haven't done the bottom right, but you get the idea. That's the last one. Again, thank you for all those who are actively participating each week. I know this is tough. It's one of those things you just got to get used to it. Wish you the best. I'm hoping that you're healthy and you're taking care of each other. And I hope to see you guys real soon.